students, my name is Chaitanya, Physics faculty at Shakthi International School. In this video, we are going to learn about an important topic of class 12th from chapter Current Electricity. Current Electricity. So the topic that we are going to see is Wheat-Stonebridge condition. Wheat-Stonebridge condition and the application of it. Okay, application in the form of meter bridge we will be learning. Meter bridge. Now let us understand what is this Wheat-Stonebridge condition and what is this arrangement. Okay, according to Wheat-Stonebridge, see, one scientist has found a way to represent four different resistors in a particular circuit shape to determine the relation between the resistance. In this, he has used four different resistors. And the four different resistors are connected in this manner with an external battery. If this is having a potential V, this is a positive and this is negative. Current always move from higher potential to lower potential, that is from positive to negative. So this is what I. So I is flowing through it, and in between you can add a galvanometer, or there will be a resistance you can take it. Now this current at this junction will get divided as I1 and I2. Let's say we are taking these resistors as P, Q and R, S. All these are having P ohms, Q ohms, R ohms and S ohm resistances. And this is some T we are taking as the resistance of this resistance which is connected in between. So now, according to Wheat-Stonebridge condition, the current I will be going in this direction. The I1 which is coming from here will be getting divided as IG and let's say I3. Now the current which is coming from here I2 will be going in this direction. Okay, since we are already assuming the current IG is coming in this direction, I2 will not be getting divided in this. So I2 plus IG, all of them will combined will give you again I. So basically in the experiment what he has observed, if the ratios of P by Q is equal to R by S, then the galvanometer which is connected to that bridge, in the galvanometer the value of current reading shown is 0. That means the current passing through I through resistance T is 0. So this is one peculiar condition, okay, which explains if the resistances are kept in this ratio, then the current that will be flowing through this galvanometer will be 0. That means this is a shorted circuit. This galvanometer completely we can remove it. Okay. So that means P and Q, you can redraw the circuit in this form. This is your P and this is your Q. R and S, they are connected. P and Q are connected in series and R and S are connected in series. You can further solve this equation to get the final. But the main application of this is to understand the ratios. Okay, is to understand the relation between resistances. That is to find unknown resistance. To find unknown resistance. Now that you have understood what is happening in the Wheat-Stonebridge circuit, if the Wheat-Stonebridge condition, that is P by Q is equal to R by S, if this is being satisfied, okay, if this condition is satisfied, then the potentials at these particular points, the potential, if you are taking this one as potential, if you are taking this point as A, B, C and D, the potential at VB is equal to potential at Vd. So Vb minus Vd is becoming 0. Since there is no potential difference, the current passing through galvanometer is becoming 0. This is the general logic. Okay. Now, how do we use to find the unknown resistance? We have developed a device called meter bridge. In this meter bridge, we are going to use a 1 meter long wire. We have taken a 1 meter long wire. Let's say this is point A and this is point B. This is a 1 meter long wire. We are connecting it to metal plates. Okay, this is how the setup is. We are connecting it to metal plates. Okay, now in between these two metal plates, we are going to add a resistance which is unknown. This is your unknown resistance. And here you are going to add a resistance box. This is your resistance box. Okay, this is your known resistance. You can take a known resistance value from here. Okay, that now we are going to connect a jockey along with a galvanometer will be connected, and this jockey, this is your jockey. Okay, it will be connected to the galvanometer and it will be connected here. Okay, in the circuit. Now if this connection, if this is how your connection is, this is actually, you can redraw this into this format. This is your unknown resistance and this is your known resistance R. Okay, since this is your galvanometer jockey, it is dividing this 100 meter wire, okay, into, let's say if you are taking this one as X, this will be 100 meters, 100 centimeters. 1 meter wire we are taking. If this is 1 meter, total length is going to be 100 centimeters. If this is taken as X from here to here, then you can take this entire distance as 100 minus X. So now X and 100 minus X. Now we are using one condition. This 100 meters wire, okay, so you can take this one as X and this one as 100 minus X of some resistance. This is going to have some resistance, this is going to have resistance. Now to understand the resistance, let's say this 100 centimeters of wire is having R resistance. So 1 centimeter wire will be definitely having R by 100. This R by 100, where R is the total resistance. Let's say if you are getting confused, we are going to use that value of R in a different form. Let's say I am going to take it as R dash is a resistance, R dash by 100. That means for every 1 centimeter, you know, R dash by 100 is the resistance. We take this ratio, that is resistance per unit length. Resistance per unit length as small r. Small r is equal to R dash divided by 100. Now if you want to find the resistance of X centimeters, X centimeters have a resistance. If you want to find R, resistance of it, R double dash, you can write it as X into R dash divided by 100. So this R dash divided by 100 can be further written as R. So R double dash, which is equal to the resistance of that X length, can be written as X into R. So R triple dash, which will be the resistance of 100 minus X. Okay, for 100 minus X, the resistance can be written as 100 minus of X into R. So further, if you are, that means the resistance that you are going to have here is going to be X into R, and this will be 100 minus X into R. Okay, now we are connecting it to an external battery. Let's say this is where the external battery is connected. Through this, the current will be flowing through. The same, you can redraw this circuit to be like this. Now, this Wheatstone bridge is working on the principle of this meter bridge is working on the principle of meter bridge balancing equation. Now, since we are having the resistance of this side as unknown resistance U, and this is a known resistance. Let's say I am taking this one as R, and the resistance from here to here, the length of this wire, and the resistance from here to here, the length of this wire is known. This is x into r. This is 100 minus x into r. We can redraw this entire circuit like this. Now, using Wheat-Stonebridge condition, when the galvanometer is showing 0 reading, that means you will adjust this jockey position in such a way on that 1 meter wire. You are going to test it by touching at different points so that the galvanometer will be becoming 0. Then you will get a Wheat-Stonebridge balance condition. Under that Wheat-Stonebridge balance condition, you can substitute u by x into r is equal to r by 100 minus x into r, small r. So these two r's gets cancelled. If you want to find the unknown resistance, you can find r into x divided by 100 minus x. This is a general formula to find the unknown resistance. Thus, by using a principle of Wheat-Stonebridge condition, we can find the unknown resistance by using this device meter bridge. So unknown resistance can be written as r into x divided by 100 minus x. This is the general formula of it. I hope you understood this well. We'll meet in the next video. Thank you.